Namaskar. I am Dr. Nisha Rani, Superintending Geologist from Photogeology and Remote Sensing Division, Geological Survey of India Training Institute, Hydrabad. My session is 7th and the topic is Introduction to Digital Image Processing Techniques. During my session, I will discuss about digital image processing, spatial enhancement, radiometric enhancement, spectral enhancement and classification techniques. Digital image processing. Digital image processing facilitates qualitative analysis of digital data with the help of computers to extract information about the Earth's surface. Image processing involves manipulation and interpretation of digital images with the aid of the computers. This is extremely a broad subject and is often involves procedures which can be mathematically very complex. Image processing involves three important steps. First is pre-processing, second is image enhancement, and third one is image classification. Pre-processing includes radiometric correction and geometric correction. Image enhancement includes radiometric enhancement, spatial enhancement, and spectral enhancement. Image classification include unsupervised classification and supervised classification. I will discuss about the image enhancement techniques and image classification in detail. Image enhancement. The purpose of enhancement is render the images more interpretable, that is, features should become better discernible. Enhancement is the modification of an image and increases the dynamic range of chosen features so that they can be detected easily. It sharpens image features such as edges, boundaries or contrast to make a graphic display more helpful for display and analysis. So here we have one diagram. We can see image input will be here and you are applying image enhancement technique, so you are getting better result. That is your image enhancement. In my previous slide I have described about the enhancement techniques. So there are three types of enhancement techniques: radiometric, spatial and spectral. Radiometric enhancement technique enhance images based on the values of individual pixels. This technique improves contrast between certain features by altering the screen colors assigned to specific ranges of pixel values. Contrast enhancement. Contrast enhancement deals with the rescaling of gray levels so that features of interest are better shown on the images. The number of actually recorded intensity levels in a scene is rather low and full dynamic range of digital images, that is 256 level, is not utilized. As a result, the image has a low contrast. Rescaling of gray levels could improve the image contrast and allow better visibility of features of interest. So there are certain common contrast methods, that is linear contrast stretching, multiple linear stretch, that is also called piecewise linear stretch, algorithm power or functional stretch, Gaussian stretch, histogram equalization stretch and density slicing. Spatial enhancement. Spatial enhancement enhance images based on the value of individual and neighboring pixels. It refers to texture of image. Smooth areas have low spatial frequency. Gray's value changes gradually. Rough areas have high spatial frequency and gray value changes abruptly. Frequency means number of changes in DN values per unit distance in a particular part of an image. There are two types of frequencies. First is low frequency, few changes in DN values over a given area. High frequency means dramatic changes in DN values over a given area. Spatial domain filtering can be divided into two: high pass filtering, low pass filtering. High pass filtering is used to enhance edge of two adjacent features. This is also known as edge enhancement. Low pass filtering is also known as image smoothing. It enhances low frequency spatial information and is reverse of edge enhancement technique. Here we can see we have two figures. One is high pass filtering, where we can see the edges are sharpened. Edge enhancement is here, and low pass filtering we can see here. our image is looking very smooth. Frequency domain or Fourier filtering is a mathematical technique for separating an image into its various frequency components and operates on one image at a time. It separates image into its component spatial frequencies. We have one quiz. Radiometric enhancement technique improves option 1 contrast, option 2 spatial resolution, option 3 resampling. The correct answer is option 1 contrast. You have another quiz. Which among the following is a enhancement technique? Option 1 de-stripping, option 2 filtering, option 3 georeferencing. And the correct answer is option 2 filtering. Spectral enhancement technique. This technique is used for compression of similar bands, extraction of new bands of data that are more interpretable to the eyes. Mathematical transformation is performed during spectral enhancement. It increases the variety of information in the display using available RGB guns. The most widely used techniques for spectral enhancement are spectral ratios or band ratio, and sometimes it is called indices. Second is principal component analysis. Spectral ratios. Band ratio is a technique where the values of the brightness of the pixels in a spectral bands are divided by the another band. Means the band which is having highest reflectance will be divided by the band which is having the maximum absorption. That is called band ratio. This is the band ratio given for the ester. You can utilize these band ratios to identify different minerals, and this is the gray imagery of band ratio 7/6 where brighter pixels are showing presence of muscovite. Principal component analysis. This transformation technique is used for reducing dimensionality of correlated data and compressed information from all the bands into fewer bands. Here we can see this is the imagery without any PCA analysis, and after performing PCA we can differentiate many features on the Earth surface, and we can correlate it with the existing geology also. Image classification. Classification is the process of assigning pixels of remotely sensed images into groups of homogeneous characteristics. Image classification refers to the task of extracting information classes from a multi-band raster images. The resulting raster from image classification can be used to create thematic maps. Classification can be two types. One is pixel based, another is object based. Supervised classification and unsupervised classification is the part of pixel based classification. Supervised classification. Supervised classification is when pixel classes have been designated by the user through identification of the sites of known classification. That is called training sites. Means if you are knowing the area, if you have idea about the area and objects, that is called supervised classification. Unsupervised classification is done by the software by categorizing pixels into a pre-specified number of statistical clusters. Means in unsupervised classification you are not knowing the area, you are just giving the command to the software and it is classifying the pixel into some group. There are different types of supervised classification such as parallel piped classification, minimum distance to means, maximum likelihood classification, spectral angle mapper classification. In supervised classification, as I have already described, that we are knowing the area, the sites which we are selecting, we are knowing the identification of the site, training sites. So we are giving the command to identify similar features in the entire imagery, and our image will be classified like this. So you can identify the different objects in your area with the help of supervised classification. There are two types of unsupervised classification. K-means clustering. This method uses an iterative approach to determine classes. Second is isodata. That means iterative self-organizing data analysis techniques. This method uses an iterative approach that incorporates a number of trial and error procedures to compute the classes. Object-based or object-oriented classification, it uses both spectral and spatial information for the classification. This process involves categorization of pixels based on their spectral characteristics, shape, texture, and spatial relationship with the surrounding pixels. You have another quiz. Which one of these are not a image classification technique? Option 1, unsupervised. Option 2, layer stacking. Option 3, supervised. Correct answer is option 2, layer stacking. Another quiz. Band ratio is a enhancement technique. Which enhancement? Option 1, spectral. Option 2, spatial. Option 3, radiometric. Correct answer is option 1, spectral enhancement. Change detection. Change detection involves the use of multi-temporal data sets to discriminate areas of land cover change between dates of imaging. Ideally, it requires same or similar sensor resolution, viewing geometry, spectral bands, radiometric resolution. It requires acquisition time of data and accurate spatial registration. For better understanding of change detection, here I am showing you Google Earth image of area. This is collected in 2008 and you can see these red circles, and same area will be viewed in here in 2020. We can see the changes which happened from 2008 to 2020. So this much development you can mark, and this one also you can see. So this is the utilization of change detection studies. Here is the list of image processing software. You can see ArcGIS software is there, QGIS is there, NV software is there, PCI Geomatica, Saga, GlassGIS, PhotoScan, and AirDAS software is there. So anybody is interested, they can try to process the satellite imagery by using these image processing softwares. Thank you very much. This is the end of the current session, and the next session will be on elements of image interpretation. Once again, thank you very much.